Yo, this is Coach Ray here with another lesson. Today we're solving radical equations, which is exactly what it sounds like. It's an equation that has a radical in it. Alright, 4 steps. Step 1, isolate the radical. Step 2, eliminate the radical. Step 3, solve for the variable, which is going to be like algebra 1, 2. And then step 4, I'm going to explain more in a minute. It's called check for extraneous solutions with Desmos. Tyson, will you scroll down again? Alright, example 1. I've got my equation, and step 1 is to isolate the radical. So the radical has all that stuff under there, 6x minus 5. That plus 10 is not under there, so that needs to go away so that my radical is by itself. So step 1 is minus 10 on both sides. Now I've got the square root of all this stuff equal to negative 7. No talking, please. Okay, at this time my radical is isolated. So step 2 is eliminate the radical. The opposite of a square root is a square. Say it again, the opposite of a square root is a square. The opposite of a cube root is a cube. Okay, so if I take the square root and square it, they're going to cancel each other, and all I'm going to be left with here is 6x minus 5. Okay, but as you know from way back in the day, whatever you do to one side of the equation, you have to do to the other. And I have to square the entire other side. So that's why I use the parentheses around that negative 7. Okay, so negative 7 squared means negative 7 times itself, so I get positive 49. All right, it's now an algebra 1, 2 problem, so I can do this quickly. I'm going to add 5 on both sides. Okay, so I've got 6x equals 54. I'm going to divide both sides by 6, and I get an answer of x equals 9. Okay, step 4 in your steps said check to see if this solution is an extraneous solution. Here's how we're going to check. I'm going to go to Desmos. All right, and I'm going to plug this equation in. So I've got square root of 6x minus 5. Okay, and then I got plus 10. And then I've got equals 3. Okay, so when I plug that in and I look, nothing shows up. I can even zoom out, nothing's showing up. Okay, so I'm going to do what Mr. Witcher taught you guys last year. I'm going to put the two sides of the equations on different lines and just see where they intersect. So let me get rid of this equals 3. And then here, because it's just a constant, I've got to put y equals 3. All right, so when I zoom out now, okay, there we go. So I can see my two lines, and they don't intersect. If they don't intersect, that means there's no solution. Okay, so there is no solution to this problem. So let me go back to our notes here. An extraneous solution, the definition of an extraneous solution is it's possible for you to do all of your math correctly, get an answer, we didn't do anything wrong, but that answer does not work when you plug it back into the equation. So let's look at that real quick. If I plugged it back in, I would have the square root of 6 times 9 minus 5, and then plus 10, and that should be equal to 3. So let's go through this. 6 times 9 is 54, or sorry, 6 times 9 is 54. Sorry, 54 minus 5 is 49. The square root of 49 is 7, and 7 plus 10 is clearly not equal to 3. Okay, so in algebra, this can happen. You can do a math problem perfectly and end up with an extraneous solution, which means that if you plug that solution back in, it actually doesn't work. So that answer is not correct. Okay, so here's what I've got to do. I always need to check, and when I found out that this answer is not correct, I put a line through it to say that x does not equal 9, and I'm going to put no real solution. So whenever you're doing these problems, when you get your answer, you're going to have to open up Desmos real quick, plug them both in, and see if they intersect.
Oh, that's it? We just leave it as a
Yes. Okay, example 2. All right, example 2. Is my radical isolated? The answer is yes. Okay, there's nothing out front. There's nothing behind it. I just have the square root of 8x plus 1. Okay, so I'm ready for step 2. Step 2 is to eliminate the radical. So how I eliminate a square root is to do square. And I've got to do the same thing to the entire other side. So notice I put parentheses around that whole x plus 2, and I'm squaring. All right, so on the left side, piece of cake, it just canceled out, so I'm left with 8x plus 1. On the right side, that is not x squared plus 4. To do x plus 2 times itself, I need a 4-letter F word to do that. FOIL. Okay, first, outside, inside, last.
No.
So I'm not going to write it, but I'm going to kind of visualize. My first times my first would be x times x, so that's x squared. My outside would be x times 2, that's 2x. My inside would be 2 times x, that's 2x. When I combine those, I get plus 4x. Okay, and then my last would be 2 times 2, so I get plus 4. All right, the blue line looks more complicated, but that is an Algebra 1-2 equation. What is the name of that type of equation? Who knows?
It's cube 3.
Nope. And I really wish you would remember the name of this equation, because then I think it would help you to solve this equation better. Say it again. Quadratic. This has an x squared. Okay, that's the biggest exponent, so this is a quadratic equation. So we know 2 ways to solve quadratic equations. We can factor it, or we can use quadratic formula. All right, but in order to use either one of those, it needs to be in standard form. This is not currently in standard form. Who can tell me what standard form looks like? Owen.
The x is on one side and everything else is on.
Kind of. Everything's on the same side with quadratics, and then we have equals 0 at the end. Okay, so I'm going to get rid of, or I'm going to move this 8x and this positive 1 over here, so I'm going to do minus 8x and minus 8x with its like term. I'm going to do minus 1 and minus 1 with its like term. And now, both of these cancel out, so I have 0 equals x squared minus 4x plus 3. So everything is moved to one side. It's set equal to 0. Now it's in standard form. You could use quadratic formula, but I'm a really good factorer, so I'm going to factor this because it's faster. All right, so I've got binomial times a binomial. X times x gives me x squared. 3 times 1 gives me 3. If I'm trying to make negative 4x out of my outside and my inside, I need them to both be negative. Okay, next, set each factor equal to 0. X minus 3 equals 0. X minus 1 equals 0. And I'm going to solve. Pretty easy. Here I'm adding 3 to both sides, so that's going to be x equals positive 3. Here I'm adding 1 to both sides, so that's just going to be x equals positive 1. I've got to check them. Okay, so I'm going to go to Desmos. All right, I'm going to plug in the left side, so I've got square root of 8x plus 1. And then I'm going to plug in the right side, and I've got x plus 2. Okay, and I'm looking for where they intersect. Yay, they do intersect. So these are not extraneous solutions. Let's see where they intersect. Here and here. Okay, and I care about x. I'm trying to figure out what x equals. So x equals 1 and x equals 3. There's 2 places where it intersects. So I've got 2 answers here. X equals 3, x equals 1. Both of them are real solutions. They're not extraneous. It is possible to have one extraneous solution and one real solution, but that just wasn't the case here. All right, last problem. I don't immediately see a radical symbol. It's hidden. Okay? This fraction exponent, though, we learned in our last lesson, this fraction exponent is a radical symbol. It's actually a cube root of this 3x plus 22 all raised to the 5th power. Okay, but I don't need to switch forms. I'm not going to. I just want you to understand that's our radical even though you can't see it. So I still have to isolate the radical. So step 1, I'm going to do plus 6 on both sides. All right, so now I've got negative 5,120 equals negative 5 times this stuff. Okay, I need to get rid of the negative 5. That's negative 5 times this stuff, so I'm doing the opposite. I'm dividing. Okay, so now I've just got 3x plus 22 raised to the 5/3 equal to, if we did this division, you get 1024. Now my radical is isolated. I could switch it to radical form and do some stuff, but there's an easier way to do this. I'm allowed to raise this entire right side to whatever exponent I want, as long as I do the same thing on the other side. Here's the exponent I'm going to raise it to. Okay, because when I have a power raised to another power, we talked about this in our last assignment, you multiply those two numbers. Picture this, 5/3 times 3/5 multiplied straight across. I get 15 over 15, yes? Same thing as 1. And 3x plus 22, all raised to the first power, is still just 3x plus 22. So I don't even need to write it. Okay, so equals, I've got to do the same thing over here. I've got to raise this to the 5/3 power. So you could do it in 2 steps if you wanted. 1024 raised to the 5th power, it's going to give you a huge number, and then do the cube root of that. Or you can plug this whole thing into Desmos. If you plug in 1024 raised to the 5/3 power, you're going to get an answer of 64. Question?
Do you mean 3 over 5 now?
Yes, sorry, mistake, sorry. Not 5/3 right here. I need to raise to the same thing I did over here. 3/5. Thank you. Was that your question, Valeria?
Yeah.
Okay. All right, so now, algebra 1 problem. Okay, a couple steps. Minus 22 on both sides. So I've got 42 equals 3x. Okay, divide both sides by 3. So I get an answer of x equals 14. Okay, always in this unit, go to Desmos, plug it in, make sure it does intersect somewhere so it's not an extraneous solution. I will tell you that this is not an extraneous solution. It does work out. So the answer would be x equals 14. Okay, that is it for this lesson. We just solved radical equations. Let's go. That is it for this video. Thanks for subscribing and clicking the bell for push notifications. I'll see you guys next time. Deuces.